Okay, Internet data analysts. Let's take a look at an example analysis in Julia. What we're going to be doing is I'm going to walk you through what I did to get started exploratory data analysis of local school districts. So in California, the state has data on standardized testing, and I live near Pasadena, and so I'm interested in how well the school district is doing teaching its kids and comparing that to neighboring school districts. You can download this entire project from GitHub, and I will put that in the comment section. Okay, let's get started. We've already shown you how to install VS Code. So I'm running VS Code, and I am in my Julia Data YouTube directory, and inside that directory is the California Schools Analysis. What I've done is I've used Weave, which is a Markdown-based literate programming system for Julia. And what I do is I create a JMD file, and then I can open it up, and you can see inside these, what they're called code fences, is Julia code, and then this is markdown text. So in the end, when I weave this together, I will get either an HTML or a PDF output. And for right now, I'm not worried about making that output super pretty. I'm just trying to get you started working with some of the data. So let's get started. In my first section here, I've got using package and then package activate and then the current directory. What that does is it tells Julia that I'm working on this project, and this project has its own environment. So in this project, there's a project.toml file and a manifest.toml file. If you look at this, this says these are the packages that we're using in this project, and the manifest says, you know, what specific versions of those packages were installed. Okay, so what I need to do is get into that package, get into that project, and import these libraries that I'm going to use, data frames, CSV, data frames, meta, etc. Okay, so in order to run that, I'm going to press the Alt key, and I'm going to hit Enter. And what that does is it starts up the Julia REPL down here, and it is going to activate the current directory. Now, if you'll look, I've opened the top level folder. So I actually want to activate the CA schools directory. So to do that, first let's find out, my present working directory is that one. So I'm going to cd into CA schools, and I pressed tab, and it went ahead and found the name of that folder. So now that I've got that, I can Alt Enter up here, and that runs everything between the code fences. Okay, so that's what the little check mark says, that after doing this, nothing was returned and everything has been activated and run. So what are we actually doing here? So we're going to download some files from the California Department of Education. That data is, and by the way, you can follow along with this by getting the GitHub and looking at this file, but you can also look at the output, because I will weave this together and you'll see the HTML. You can also work with the Jupyter notebook which allows you to interact even though you're not in VS Code. But anyway, the data is available at this site. We can, I can follow that link and I can see the site. There's different versions of the files in different years, so you're going to have data files like this where it says CSV version 3 and this one is CSV version 2 because they revise the data and sometimes it comes out and needs a new revision. So here's what we're going to do. In order to get this data, we'll create a new code fence here and we'll set up the versions. So 2015 happens to be version 3. 2016 happens to be version 3. 2017 happens to be version 2. 2018 happens to be version 3. I just had to go manually look those up. Okay, so what this symbol right here means is it forms a pair. A pair is a kind of a tuple. It's basically just two things stuck together. And what I can then do is I can, go across this array of pairs, and I can find out, simultaneously, for this year, that's the version. Okay? So what I'm going to do is I'm going to create a set of files that we're going to download. This thing here is called a list comprehension. What it says is create an array, that's what the brackets mean, and it's going to be an array of these things, and that's a string with interpolated values, okay? And then we're going to interpolate it for VV being a dummy variable that goes across the versions array. Okay, so it'll first make VV this, and then it'll make that, and then it'll make this, and then that, and then this, and then that. It's like a for loop, but it's a very simplified syntax for a for loop. And then we're going to take, the year goes here, it's the first thing in the pair, and the version goes there, it's the second thing in the pair. Okay, so let's run it, see what we get. I hit Alt-Enter, and it runs everything in that code fence, and you'll see that what I got was this vector that has these strings in it. And those are the file names. Okay? We also need some special files, a entities file. Okay, so this tells you sort of the names of schools and school districts and so forth. A tests file, which describes the different kinds of tests that they might have scores for. And then a student groups file, which tells you, these files up here have the data for all student groups. And a student group might be something like, male students or female students, or students with a certain level of, the parents have a certain level of educational attainment, or students that are homeless, students that are economically disadvantaged or not economically disadvantaged, and so forth. So they've created averages across those student groups. You never get the individual student data, but we might want to look at subgroups, and so we're going to get those files. Okay, so the push function. Push, this little bang at the end, the exclamation point, indicates that the push function alters some of its arguments. That's just a convention. It's not required, but you should always do it. When you write a function that alters an argument, put a bang at the end. In this case, it alters the files argument by pushing this value onto the end of it. So we're going to push that onto the end, this onto the end, that onto the end. And we're going to wind up with a slightly enhanced list of files. Okay? So now we can see that we've got those three things at the end. Okay? Now, in order to download the data, we want to change directory into the data directory, download the files, unzip them, and then cd out of the directory. And we want to make sure that that's all done sort of all at once. We're going to use a try finally block. Okay? The way this works is it says we're going to try to do this stuff, and no matter how we finish doing that, at the end we're going to do this. Okay? So that means if there's an error in here, we're going to do that. If we just finish it because we got all the way to the end, we're going to do that. Doesn't matter how we get out of this block. At the end, we're going to do that. So we're going to cd into the data directory, which you can see is in the repository here. And when you check out the repository, that'll be empty. We're going to cd in there, and we're going to, show progress every 3 seconds of this loop. Okay, so show progress is a macro. That's what this @ means. What a macro does is it grabs all of this code. It rewrites that code in some way using Julia to modify the code, and then that code is handed to the Julia process to execute. So it's a way of writing what you might call, domain-specific languages or special operators that can create new syntax. So what this thing comes from the progress meter package, and what it would do is, if this takes a really long time to download, tens of seconds or whatever, it will sort of create a bar that goes across, and you can see how far along you've come. Okay, so after we've what we do is we check to see if that file, so we're looping over the files in the files vector of strings. So we say for f in files, what files is a vector, so it can iterate across this vector, making f be each of the different things in that vector. We're going to execute this. If this is already a path, in other words, there's already a file there with that name, then we'll skip it. If it's not a path, we'll download it. Okay? And then we're going to run unzip-u on the name of the file. And what that does is the -u basically says it's going to extract the data and overwrite whatever's there, if it's already there, without asking. So we're going to have extracted all these things, and then finally we're going to cd back to our current directory, and then we're going to take a look at what's in data. Okay, so I happen to have already downloaded all of this stuff, so this is going to go fast, but it'll go slower for you. I'm going to hit Alt Enter, and it's going to run, and it's done. Okay, so you can see that this is the output from the unzip command. It unzipped each of these, and then it read the directory and gave you back, these are the files. Okay, so the ones that end in .txt are the ones we're interested in. The zip files are the compressed version. Okay, so we have all the files, right? So what do we need to do? We need to read in the data and then start subsetting it and so forth. There's some complexity here, and I'm just going to stop after we've gotten through this section. And there's some complexity, and you could handle it in different ways, but this is what I'm going to do in this case. I'm going to create empty data frames for the test scores data, the entities data, the tests data, and the students data. Okay, these are empty data frames. I have a cache directory that's on a fast flash drive, and I'm going to use that to put output files. Okay, and what I'm going to do is I'm going to either read in the cached output files, which are arrow files, and I'll talk about that in a second, or if those don't exist, I'm going to go ahead and read each of the individual text files and put them into a data frame, and then at the end I'm going to write out those arrow cache files. Okay, these are going to be much faster to read, which is why I'm doing that. So in the future, instead of waiting like 10 or 15 seconds to read hundreds of thousands of lines of CSV, I can just memory map these things in and then turn them into data frames up here. Okay, so let's walk through this code, and then we'll be done. You can come back for the next video. Okay, so I've got the cache dir. If it's a path, tests.arrow in my cache directory. So I join the path, the cache directory, and the name of the file joined together. This function handles, no matter what operating system you have. So if the separators are / or the separators are \, it'll handle that. It checks to see if I've got an arrow file. If it does, it tries to read all the arrow files. Okay, so what it does is it creates a data frame from an arrow table. The arrow table function basically just reads in this arrow table. And the way arrow files work is that they're binary files on disk, and you can read it in by doing a memory map. So it just pretends that it's in RAM. And when you actually need to read a piece of the RAM, the operating system will go to the disk and grab it. So that means that this operation of creating an arrow table is, milliseconds or less. You don't have to actually read anything. And then when you actually go to create a data frame and it starts asking for the table entries, then they'll be read off the disk just directly into RAM and immediately get, formed into the data table. So we do that and I tell it, I want to deal with these globals. I tell it how to read each of these files. Okay, but if this doesn't exist, let's talk about what needs to happen. What I do is I need to do a loop over the files that I'm interested in. So I read the directory using readdir. That's the data directory. It's going to give me a vector of file names, and I'm going to filter that vector of file names using a predicate ends with .txt. Okay, so this creates a function which checks to see whether its argument ends with .txt at the end, if it's a string that ends in that. So then this is an iterator over just the names of files that end in txt. Okay, so I'm going to show f, and this is a macro, so it basically is doing some printing of what f is each time through the loop. I check to see if the word entities occurs in f, and if it does, I'm going to read that entities using CSV read. Okay, so I read the join path of data and f. I read it into a data frame. I tell it to normalize the names, so the names of the data columns often have things like spaces in them, and that's really inconvenient. So this will do things like make that an underscore, or if there's some other weird names that can't be used, it'll modify the names. And it turns out that this file is delimited with carets, right? So caret delimited. It's a CSV file, except instead of commas, it uses carets. Okay, so the same thing, I check to see if it's not that, I can check to see if the word student occurs in f, and if it does, I read into the students, the same thing. I make a data frame, normalize the names, that's also caret delimited. All right, if it's not that, I check to see if it occurs in tests. If it does, then I read in the tests data. Okay, otherwise, it's a little bit more complicated. The other files, if you look here, they're yearly files. So 2015, 2016, 2017, there's no 2020 because of COVID, and then it goes up through 2021. And they don't all actually have the same columns. Sometimes they have extra column names than other files don't have. So what I do is I read this data frame in, whatever that file happens to be. I read it as a data frame, and I ask it to normalize the names, and that's all good. And then I tell it append bang. So the bang there means it modifies something. And in this case, it modifies test scores by appending the rows of df. And it does so in a way where the columns are the union of the two data sets. Okay, so every column that's in here, which isn't in there, gets a null put into it. And every column that's in here, which isn't in there, gets a null put into it. And if there's extra columns in here, they're added on to the end, and those get nullified where it was not available. And in the end, what I have is all the column names that were in here and that were also in here. Or that were also in here, right? No matter what it is, the set of column names is the total union of all the column names. So this allows us to handle the fact that there's not the exact same columns in every data set. Okay, by the time I've run through all of these, then test scores has been appended from each of the files that we care about, right? Each of these SBCA files. Okay, and so we have all the years. Let's come back down. We've got all the years by the time we're done with this for loop. And so what we can do at this point is we can cache these in this nice binary format. So I just arrow right each of these. Okay, so that next time I run this, it's just going to see that the arrow files are there and then just read them in quickly. Okay, trust me that it takes on my computer something like, I don't know, 30 seconds to run through all the CSV files and do all the parsing. But I'm going to run this right here, come down here, Alt and Enter. And since I have the arrow files already, let's see what happens. Bang. So that took a little longer because it had to compile certain functions. Probably it had to compile the arrow table file function. Something like that. But if you see I run it again, I'm just, that was what, 3.8 million rows that it read. And watch, if I Alt Enter again, it read that whole 3.8 million rows in, I don't know, less than a second. So it's pretty convenient to be able to read in these arrow files as caches. Okay, so basically we've gotten to the point. One last thing, I guess what we'll do is one of these columns that we care about will get parsed as a string rather than, but it's actually really numbers. It's scores for the students. And so it can also be either numbers or missing values. So what we're going to do is we're going to create a function called float or miss x. What it does is it says if x is missing, then we'll just return missing. Otherwise, we'll try to parse a float 64 and let that be v. And if v is nothing, which happens when the string doesn't contain a printout of a float 64, then we'll output missing. Otherwise, we'll just output the parsed number. Okay, so at the end of this, we're going to either get nothing, or sorry, we're going to either get missing, or we're going to get a float 64. And so, and then what we're going to do is we're going to tell it to run that across the test scores.mean scale score value. And these are floating point numbers that are students' scores on the tests. So this little period here is significant, okay? What it tells you is when you put a period at the end of a function, it means take this function, loop over this iteratable thing, okay, and apply that function to each value in this vector of scores, and then return a vector of the results. So we're going to turn the mean scale score into, either floats or missings created by broadcasting, which is what this dot does, the float or miss function all the way across this entire vector of scores. Okay, so we're going to Alt and return, and then it's done. Okay, so it gave us all these scale scores, and some of them are missing, and then we've now got analyzable data, and we'll continue from there in the next video.